So good afternoon, everyone. As Roland mentioned, my name is Manfred Lee. I'm part of the product management team. Specifically, I oversee a lot of the Ion instrumentation, so PGM, Proton, One Touch, some of the new instruments that we're currently developing as well. I really want to first thank everyone here for making the trip out to Portugal to be with us. For the hundreds of you who are watching this broadcast, thank you again for taking time out of your day to watch this. We've got some really exciting content for you today about some of the developments that we're doing here on PGM and Proton. And really, at the end of the day, what we're all here to do is really look and see the promise of a highly disruptive technology in semiconductor sequencing. And we really do believe that this is a highly disruptive technology, as semiconductors have disrupted music, books, photography. We see the very same thing taking place with the PGM and shortly coming to fruition with the Proton itself. And so the theme that you're going to see time and time again over the course of a number of different innovations that we'll be announcing today to you is one of continuous improvement across the PGM platform, across Amp Seek, across Proton. Really, we're at a interesting turning point in the development of ion semiconductor sequencing. We've proven ourselves out with the PGM over the last 18 months. We have a killer application in the form of Amp Seek that many of you have taken advantage of over the past year. And of course, we just launched Proton and are just getting started there. And we see Proton as taking our level of throughput to the next higher level of genome scale sequencing. So with that, we're going to start with the PGM system. And really, first and foremost, thank you to each and every one of you for making PGM the success that it is today. For those of you who are considering the purchase of a PGM, our install base is now over 1,000 units strong. And it's become the most fastest selling sequencer in next-gen sequencing. And with that 1,000 install base, we've now developed a scientific community of over 13,000 members who are on the Ion community, logging in, getting the latest protocols, getting the latest applications. If you've never been on the Ion community, it's a completely free resource. Do check it out. It's ioncommunity.lifetechnologies.com. For those of you who are already customers, you obviously have access to it. For those of you who are yet to be customers, you can access that resource and get the latest download on everything that's Ion related. You'll get discussion threads, you'll get some of the latest programming and events, and there's a little bit of fun on the community as well, which is our recognition awards program, where people can upload their record runs, get awards for contributing to the community. What you see here is, as of this morning, the 3 record runs for 314, 316, and 318, as well as the handles or code names or login names for those folks. Interesting point here, Lindsay joined the Ion community about 2 weeks ago, and within 2 weeks posted a record run, just really demonstrating how rapidly she's able to get up to speed on that platform. And she's got 5,000 points for that, and we'll be getting $5,000 for that. And so, again, people who are accessing PGM for the first time are really seeing a rapid pace of change there, and being able to get exposed to some of those rapid improvements and translating them into record runs. Case in point, over the last 18 months, we've consistently improved our read length and accuracy over the course of the last 18 months on the PGM. We started off with 100 base pairs. This quarter, so within the next few months, we are releasing the 400 base chemistry broadly to everyone. It will be available, it will be orderable. Our 400 base pair chemistry marks a very exciting turning point for the PGM. Specifically, it'll enable things like de novo assembly, metagenomics, DNA and RNA structure, and gene fusion studies. So we're really excited about getting that into the hands of everyone. In addition, those 400 bases don't come without a significant compromise to accuracy. You can see here the cumulative base accuracy here is above 99% for the data set that's currently publicly available on Ion Community. In addition, for some of the most difficult sequences in the genome for us to sequence, namely homopolymers, we've seen a significant improvement with our homopolymer accuracy with the advent of Torrent Suite 3.0 and the more recently released 3.2 software. Torrent Suite is our solution for signal processing, base calling, alignment, and variant calling. The latest version of Torrent Suite enables a detection of 6 mers with greater than 99% accuracy. In certain samples, we've actually seen 9 mers and 11 mers called as well in terms of insertion deletion mutations. So a lot of improvements on the accuracy front, a lot of improvements on the read length front, and those are improvements that are shortly coming within the next few weeks in the form of new template prep kits and new sequencing kits. And this isn't just an experience that folks have had internally, our R&D scientists have internally. This level of innovation and level of improvement has been something that's been experienced by our install base. For example, this was a presentation that was given by Chad Nussbaum at the Broad a couple of weeks ago at our Ion World event. And what he's seen over the past 18 months is a rapid improvement in the quality of our data, decline in the mismatch error rate, as well as a significant decline in our insertion and deletion error rate. Again, with the advent of new software as well as new chemistries coming online. And so the net effect of this just on the PGM alone is that we continue to innovate on this platform. With 400 base pair chemistry, we expect a significant ramp in the overall performance of the 314, 316, and 318 chips. That will result in without significant compromise to quality, where the majority of bases generated across these chips will still be above Q30. And this is really the theme of what Ion semiconductor sequencing has been over the past 18 months, is just continually rapid improvements, new protocols, new kits to ensure that you get the maximum benefit out of that system. And really at the end of the day, that reflects the semiconductor sequencing technology. You can really think of the hundreds of scientists and engineers that are working for Ion today. They can come up with an idea in the morning, generate a data set by pulling a couple of runs onto the PGM, and within a day or so have at least a sense of whether or not the ideas they have for enhancing accuracy, enhancing throughput, enhancing read length, covering a broader range of applications like Amp Lesion, really have a sense of whether or not that's feasible. And within a week or so, they can generate a significant bolus of data to be able to look at whether or not there's more R&D that needs to be done, or whether or not there's a commercialization path they can pursue. And that's, again, reflective of the speed of the platform. So that's the PGM system. With the PGM over the past year, we had our killer application with Ion Amp Lesion. It's been a great application for our customers, specifically for targeted resequencing. We know that our customers are interested in specific pathways of interest, specific genes of interest. They're not necessarily always in discovery mode, looking across a broad cast of genes. So instead, what we have is targeted resequencing for Amp Lesion on the PGM. The reason why people have gravitated toward that application is really, one, low DNA input requirements, about 10 nanograms, a single tube amplification for certain pool designs, and of course thousands of amplicons covered in both our fixed as well as your custom panels in design. But as great as that experience has been for Amp Lesion, we're not going to stop there. We're going to continue to innovate there. First thing that we're doing on the custom side is currently we support up to 3,000 amplicons. We're moving in the coming months to 6,000 amplicons. In terms of single tube amplification, so you'll be able to look and interrogate up to 6,000 different amplicons in a single tube. We're also looking at improving coverage uniformity. For us, coverage uniformity really means lower cost per sample for you. That enables you to effectively drop the coverage requirements and effectively look at more samples interrogated per chip itself. This is an example of what you'll see on the cancer panel that we've developed in terms of improving coverage from this particular dropout early in the reads all the way to today. And that'll significantly reduce the cost per sample for these types of panels, as well as for your custom panels. Last but not least, we've heard a ton of feedback from everyone about their interest in non-human models with Amp Lesion, and I'm happy to announce today that in the coming months, we're going to be supporting Amp Lesion on non-human models. We're going to start off with mice and mouse models, and then quickly move to other models in the coming months as well. So please do be on the lookout for Amp Lesion. We're going to continue to innovate on Amp Lesion in terms of content so that you can do targeted resequencing, not just in humans, but across other experimental models as well. I'm just going to take a moment here and call out a few folks on the product management team that I encourage you to speak to about Amp Lesion. Basically, anyone in a black shirt, you can generally ask questions about Ion Torrent. But in terms of Amp Seek, Anoop, if you can stand up or wave your hand. Anoop's back there. If you have any questions about Amp Seek Designer, custom Amp Seek, fixed Amp Seek panels, Anoop is your guy. We were certainly happy to answer any questions, but he's the man with a lot of insight into the Amp Seek platform. So last but certainly not least, Proton. We see Proton as effectively an extension of our philosophy about PGM, which is making next generation sequencing as accessible and as affordable to as many people as possible. And we're able to do this with the Ion Proton System, which brings human genome scale sequencing to every laboratory. The Proton itself is about a third the cost of other high throughput sequencing systems. Thank you very much if you've already invested in that technology. And we're able to do this because, one, the nature of the chips themselves enable us to have a low cost per run, but equally important is the fact that almost all of the interrogation of that chip is done either electronically or fluidically, which means that we're able to bring a relatively low-cost technology to bear on the marketplace. And in fact, the Proton has some of the latest cutting-edge electronics that are available to computers today. We actually have a strong collaboration with Intel, who put a team of engineers on the Proton for us to ensure that, for example, our motherboard and the microprocessors that we use from Intel were able to keep up with the amount of data that was coming off the chips themselves. So a lot of people, even outside the industry, are really keeping an eye on the Proton. They see it as a highly disruptive technology, and it's something that we're really excited to bring to market to bear today. So we're first going to start with the P1 chip, which is available now for as little as 950 euros per run. That includes both the template prep reagents, the sequencing reagents, as well as the chip itself. The Ion P1 chip will support throughputs of up to 10 gigs, as well as 60 to 80 million reads. There's been a lot of confusion, I think, as far as desktop, benchtop sequencers, specifically Proton related to PGM related to other competitors. And really where we see Ion's Proton sweet spot right now is really in the number of reads that it generates. 60 to 80 million reads on the P1 chip is unsurpassed by any other benchtop sequencer that's out there to date. We'll show some data for exome as well as transcriptome, but those number of reads are absolutely critical for you to be able to do a targeted application like exome, where you have a probe pool. Those probes are effectively require coverage to be able to hit them, and you need reads for coverage. With 60 to 80 million reads, it's also a fantastic platform for transcriptome analysis as well. So that's something that's unique to the P1 chip. With P2, we're going to scale 4x. We're looking at 240 to 320 million reads on the P2 chip, up to a 20x human genome that will be capable on the P2 chip. And all of this will be with 200 base read chemistry initially and runs in a couple of hours. So for those of you who have invested in Proton, many thanks for taking the first step to acquiring the Proton technology. Last quarter, we shipped about 100 Protons worldwide, and we intend to fully install and ramp those up over the course of this quarter. For those of you who've already received your Proton, really do appreciate your cooperation as the demand has been huge for these units. We will be working closely with you in the coming months to get your site ready, installed, and trained on the Proton itself. And we've got a fantastic field team as well as an internal concierge team to help you through that process. If you haven't received an email or been contacted by the concierge team, they are your point of contact. Largely for helping you navigate through the installation and site preparation process. They can be reached at ion.concierge@lifetech.com, and they will be absolutely helping you in the next coming weeks to ensure that your Protons get up and running. And so what we showed 2 weeks ago was a number of different experiences that some of our customers have had with the Proton, and this is effectively just one slide in a nutshell. If you're interested in seeing a lot more data on the Proton itself, please come speak to me. I've got a number of different slides I can show you. Also, please do speak to your local sales representative as well. But what we showed over the course of that presentation was an 11.5 gig run where the average uniformity of coverage was about 100x across that run, consensus accuracy of about 99.99% or greater in terms of SNP and indel variants called. More importantly, we saw a high uniformity of coverage. Greater than 90% of the bases across that exome data set were covered at 20x or better. You know, most targeted approaches and sequencing approaches today, most of the quality of an exome is usually somewhere in about 80–85% of map bases covered at 20x or better. So the Ion Proton system really makes human exome sequencing routine from our perspective. We've coupled this with a fantastic upfront targeted exome library kit, which is our Target Seek exome kit, which will enable you to pull down exomes, not only just exonic regions, but also non-coding RNA regions as well. The other thing that we're thinking about is more of a complete solution. We know that a number of people who are looking to get into high throughput next generation sequencing for the first time may not have the bioinformatic resources. They may be working with just large data sets for the first time. And so we've coupled the Proton with Ion Reporter coming out in a few weeks with software that will support multiple types of exome analyses in the cloud. Specifically, it'll look at single exome workflows, paired exome workflows, as well as trios for inherited disease. You push those files into the cloud. You're able to then generate variant calls from the Ion Reporter pipeline, as well as has a fantastic graphic user interface to be able to visualize variants. And we know that those variants are not useful without some biological insight. So we've also partnered with Ingenuity and their variant analysis pipeline to be able to quickly take those variants and identify and associate some biological relevance to them. Ingenuity is a really interesting company where they've curated over 4 million publications manually, literally reading through those publications and identifying the scientific and biological basis of a variant to a biological function. And so when you have these variants in hand and you push it through the Ingenuity pipeline, you can at least get some hypotheses about what pathways are being impacted, what regions of the genome are being impacted, what cell functions or metabolic processes are being impacted. So it's a really interesting application and a great partner for us in terms of making sense of your data moving forward on the Proton. If you have questions about Ion Reporter or Ingenuity, we'll have a number of different workshops over the next couple of days. But for those of you who are in the audience, Matt Dyer, if you're around, Matt's in the back there. He'll be able to answer any questions you might have about Ion Reporter as well as Ingenuity. Yeah. So the other application for Proton that we have a lot of excitement around is our counting applications, specifically RNA Seek and chip seek, where the number of reads really matter, and you know, you need that depth of coverage for a whole transcriptome analysis. What you see here was data presented by Dr. Tim Trish a couple of weeks ago from the Children's Hospital of Los Angeles. In collaboration with us, he took a MAQC Universal Human Reference. These are 6 consecutive runs done on a Proton with a couple of interesting kits up front. So what we did was we took an RNA sample, the Universal Human Reference. We ribo-depleted that using the ribo- eukaryote V2 kit from our colleagues at Ambion. And then put it through our total RNA Seek library preparation kit. So this is a ribo-deplete. It's not poly-A in terms of the nature of the library being shown here. And what you see here is 60 to 80 million reads being routinely generated across these 6 consecutive runs. Of those 60 to 80 million reads, about 65% of it mapped. Which is a fantastic mapping rate. We were able to detect over 16,000 genes in the ref gene database, which accounts for about 75% of those genes. With P2, we only scale up from there. That'll be about 320 million reads on the P2. So if you want really deep transcriptome analyses, P2 will be one path. If you have less stringent coverage requirements, you can now do multiple transcriptomes with P2 as well. So for any questions that you might have about our upfront solution for transcriptome, we've got Tom Biddick, as well as Kelly. If you can stand up in the back there, please do ask them questions about our fantastic ribo-depletion kits up front for the Proton themselves. So reads is definitely one metric, but what about the quality of the data itself? And we think of quality in terms of reproducibility, sensitivity, and correlation to known gold standards. And what you see here on the left-hand side is our our data to look at reproducibility. We're taking consecutive runs and looking at pairwise analyses. The mean correlation coefficient across these two pairwise analyses was about 0.99%, so the data is highly reproducible. You also see that the sensitivity is across 6 logs of dynamic range. So again, a high level of sensitivity in terms of detection. We also took this data and then mapped it to known TACMAN assays, looked at log 2-fold changes in gene expression relative to another reference, and then looked at correlation of those 2-fold changes to gold standard TACMAN assays that we have available at Invitrogen and Life Technologies, and again showed a correlation of about 0.958 across those assays, across all the assays that we have available for TACMAN. So not only is the data highly reproducible, not only is the data sensitive, we see that it is in fact, these are real results that are validated by TACMAN. So that's RNA Seek on Proton. We think counting applications, again, are a major source of, major area of application development, specifically for the Proton. Given the number of reads on the P1 chip, it's unsurpassed by any other desktop or benchtop sequencing instrument that's out there. And if you're interested in counting applications like RNA Seek, ChIP-seq, the P1 chip and the P2 chip will absolutely support those applications. So last but not least, I thought just given the setting, it made sense to think about talking about how we're going to make your sequencing life easier. This is a fantastic setting here. I think many of us, when you think about next generation sequencing, you think about workflow, you think about some of the challenges of the workflow, and we're absolutely continue to innovate on a number of different fronts in terms of instrument as well as chemistry on template preparation. The first thing that you all have access to right now is the Ion OneTouch 2 spec sheet. For those of you who are watching this broadcast, you can learn more about the OneTouch 2 online at our website at lifetechnologies.com. Originally, the OneTouch 2 was brought to bear to support Proton, which has been the announcement that we've made over the past year or so. But I'm happy to announce today that the OneTouch 2 will also be fully backwards compatible to the PGM itself. It's simple to set up and use. It's a modular workflow. We went down the path of making it far more modular versus integrated because we realized that multiple people may be accessing the technology. So to be able to do template preparation in parallel with sequencing, you do need a modular workflow as opposed to a fully integrated workflow. So this type of setup enables you to have the maximum flexibility to access multiple and different parts of the workflow itself. And most importantly, it's robust. We've had some challenges, no question about the OneTouch over the past year. And we've taken a lot of those lessons learned, continue to improve the OneTouch now with the disposable line configuration. But we've also taken those lessons learned and poured them into the OneTouch 2 as well. And this, in fact, is the version that we're going to be, we are filing our CE IVD and diagnostic filings for moving forward in 2013. So we think we have a much more robust platform moving forward for template preparation with the OneTouch 2 system. For those of you who have already invested in OneTouch, you can come talk to me. We'll be talking about a really affordable upgrade path to the OneTouch 2 in the coming months that are available. For those of you who are going to be investing in PGM for the first time, you will automatically be getting the OneTouch 2 moving forward. A step up from the OneTouch 2, we announced the Ion Chef recently. Ion Chef for us is effectively the unification and simplification of our entire front-end workflow, so both template prep and chip loading. The concept of Ion Chef is really library in and 2 loaded chips out. And we're able to do this because we have a fully automated robotic platform that we're developing. This robotic platform doesn't come at the compromise of size. It is going to be a benchtop-based system. It's much simpler to access. We have cartridge-based reagents that will be used as opposed to individual reagents that you're handling. You'll be able to load your chip, close the system, and effectively hit go. It's higher throughput than the OneTouch itself. It's going to enable loading of up to 2 chips, and then there's a ton of flexibility in the actual Ion Chef itself. It will support both the PGM 3 series chips as well as the Proton P1 and P2. In addition, it'll support 200 base pair chemistry, 400 base pair chemistry, and beyond. And that's simply the fact that everything that we anticipate we need in the coming months to be able to support longer reads is effectively slight modifications to liquid handling, so to speak, and changes to reagent kits. And we can port all of that onto the Ion Chef so that it has future proofing in it. So this is our premium sequencing preparation instrument. We'll have both OneTouch 2 out now. Ion Chef will be out halfway through 2013. And really, at the end of the day, we think this is as a means of fully sequencing and integrating our front-end workflow and make your life as easy as possible. In addition to the instrumentation, we've taken a long and hard look at template prep chemistry. We know that there's some baggage with emulsion PCR, and because of that, we've done everything we can to try to automate that process, remove some of the manual nature of emulsion PCR from the workflow. But in addition to that, we've been actively looking at ways in which we can move away from emulsion PCR altogether. And with that, most recently, over the past year, we've been working on what we call the avalanche chemistry. Avalanche chemistry is a 30-minute non-emulsion long-read template preparation chemistry that we've been developing. It's isothermal amplification. It's fast. We'll definitely be targeting a 30-minute front-end amplification scheme, but internally we've seen amplification times as little as 10 minutes for some of these isothermal amplification experiments. So we have a lot of excitement around Avalanche. We think it's going to bring to bear a lot of simplification to the workflow. We think that it's going to bring to bear ultra long reads as well. Incidentally, what you see here is a 318 run done recently, about 540 megs generated of Q20 data, 117x mean depth of coverage. This was shown about 2 weeks ago. Since that time, we've already internally generated 625 base pair perfect reads with the Avalanche chemistry as well. So we're seeing a very rapid trajectory on the Avalanche platform. Really look forward to getting this to you in 2013. A lot of questions have been asked, is this wildfire based? Wildfire is a fantastic technology for solid. It is not wildfire based. If you do have questions about wildfire solid, right over here, Martin. For those of you who have questions about wildfire solid chemistry, please do talk to Martin. He'll give you some insight there. The other thing about being able to rapidly iterate internally, come up with a few ideas, generate some data, demonstrate feasibility, and then do more R&D is that it actually opens up entirely new avenues of product development that we may not have considered early in our product development roadmap for some of our technologies. Case in point, when we started with Proton, we really envisioned only P1 and P2 in terms of development. But with the advent of the Avalanche technology and our ability to increase the efficiency of templating, get much higher signal, get much higher densities of templating, we now see a path to P3 for us moving forward in the next 18 months. And P3 is effectively a doubling of the P2. We'll go from 660 million wells to 1.2 billion wells. And this is really largely enabled by some of the things that we've been developing on Avalanche, some of the other things that we've been developing internally as well. And so we have a full roadmap from 3 series all the way through P3 that enables you a wide range of application development and application support. And as we've seen with the 3 series going from 10 megs, 100 megs, and up to 1 gig, with the 400 base pair chemistry now significantly enabling much higher throughputs across all those chips, we expect that in the coming year, the same thing is going to be happening very quickly with the P series chips as well. As we continue to ramp up the template preparation, as we continue to improve the chips themselves, as we continue to improve the software algorithms in terms of signal processing, base calling, alignment, all of those things are going to enable us to continue to push the envelope of this particular technology, ensure that you get maximum performance out of both the PGM and the platform. So the last plug I'm going to make is that in 4 weeks, we're going to be at ASHG 2012. Do encourage you to keep up with some of the things that we're going to be talking about. There will be far more information about P2 at that time, P3, as well as Avalanche. I do encourage you to come see us if you're headed out there to San Francisco. If not, keep your eyes peeled both on the community as well as in press releases. We will be making a lot more exciting announcements over the next 4 weeks. So with that, thank you very much for taking the time, coming all the way out here to Portugal. For those of you on the broadcast, thank you so much for taking time to listen to some of the exciting developments that we have on both the PGM and Proton. I'll take questions.